we have finally made it to the last lesson in this chapter, and it's going to be a pretty big one. It is Module 6, Lesson 6, involving inequalities. And I'm going to tell you right now, inequalities are the easiest thing in the world that you guys are going to freak out and get screwed up over. You work them just like you do equations, with one teeny tiny little difference. And for some reason, that one super easy, teeny tiny little difference makes your little heads explode. No exploding heads today, guys. Pay attention, learn that one difference, and you're going to see how easy these things can actually be. So, our content objective, students will write, solve, and graph inequalities. The pacing guide says this is going to be a whopper of a lesson, and since it's going to be a whopper of a lesson, we probably ought to hurry up and get started on it. So let's go. Fishing charters, that's something that means a lot to some of y'all down here because a lot of y'all's families make money that way. Fishing charters are an opportunity to rent a boat with an experienced captain to venture out to sea and fish. When fishing, there are rules for what types of fish you may keep and how big they need to be. While fishing is a popular sport, regulations like this hope to keep a healthy population of young fish in the water, and some common types of saltwater fish such as grouper, mackerel, and snapper, or even billfish, the big ones that everybody likes to catch and see jump out of the water and stuff. In saltwater fishing, any grouper that is caught may be kept if its length x in inches satisfies the inequality x is greater than or equal to 20. An inequality is a statement that compares two quantities that may or may not be equal. Any length of grouper that does not satisfy this inequality must be released back in the water. Ollie caught a grouper that is 26 inches long. How do you think Ollie can determine whether or not he can keep the fish? Well, this is part of what we're going to be learning about in today's lesson. An inequality is defined as a mathematical sentence that compares quantities that may or not be equal. As highlighted in green, it is going to be one of your vocab words on your vocab quiz. The table shows 4 inequality symbols, and you can see them right here. You've got greater than, less than, greater than or equal to, and less than or equal to. A solution of an inequality, this is important here, a solution of an inequality is any value of the variable that makes the inequality a true statement. So for example here, x plus 1 is greater than 6. That means x would be any number that you would add to 1 that would give you a value that is greater than or equal to 6. So for example, if I put 6 in for x, 6 plus 1 is 7. 7 is greater than or equal to 6. That makes 7 a solution to the inequality. They give you example answers here. 5, 6, 7, 8, 9, and so on are all values you could put in for x that would be valid solutions to the inequality that they gave us. Now, if you look at what these different inequalities mean in words, this is greater than or more than. This one with the bar under that means greater than or equal to, otherwise known as greater than or at least. So, for example, if I told you that you needed at least $5 in order to be able to buy lunch today, that means that if you have $5 and a penny, you can buy lunch. If you have $5, you can buy lunch. But if you have $4.99, your tummy's going to be rumbling. Less than, also known as fewer than right here, and then less than or equal to with a bar under it means that it can be equal to the number or less than the number. Now let's take a look at what these cards say about solving real-world inequality problems. What you want to bet they're going to say pretty much the same thing as all the equation problems we worked in this module. So, describe the mathematics of the problem, use only the most important words, identify the key words. I think that's the same thing they've said in the previous 4 lessons. Variable, define a variable to represent the unknown quantity. Yep, that's the same thing too. And then finally, translate the words into an algebraic inequality. The only difference here is this one word, inequality, was equation in the previous 4 lessons. Now we're working with inequalities instead of equations, but everything else is going to work pretty much the same. And now let's enjoy a word from our sponsor on how to solve these.
A person must be at least 18 years old to vote. You are asked to write an inequality to represent the possible ages of a voter. To write an inequality, start by describing the situation. Identify any key words and numbers. For this problem, you know that a voter must be at least 18 years old. Next, use the key information to model the problem with words. Because a person must be at least 18 years old to vote, a voter's age could be equal to 18, or it could be more than 18. So, the age of a voter is greater than or equal to 18 years. Now, define a variable for the inequality. The variable should represent what you are trying to find. In this case, you want to determine the possible ages of a person who can vote, so let the variable a represent the age of a voter. Finally, use the word model to write an inequality. The age of a voter is represented by the variable a. Show that a is greater than or equal to 18 by using the greater than or equal to symbol. So, an inequality that models the situation is a is greater than or equal to 18.
Well, I think you'll agree with me that that is very similar to what we have been doing in our previous lessons, so let's get on with it and actually start applying some of this stuff. And so we have example 1 that says, in some states you must be at least 16 years old to have a driver's license. I think that's most states. Some states even have to be older. Write an inequality to represent the age at which you can have a driver's license. In Germany, we had a German exchange students, and you had to be at least 16 years old before you could go to a bar. But you had to be, I think it was 18 or 19 years old before you could drive. I guess they wanted to make sure you knew how to hold your liquor before you got behind the wheel of a car, I don't know. But anyhow, let's work on doing this. Write an inequality to represent the age at which you can have a driver's license. First things, describe the mathematics of the problem. In order to have a driver's license, you must be at most equal to or at least, that's going to be at least 16 years of age. Go into your next slide. Defining the variable, we're going to let a variable a represent the age to have a license. That sounds good. Definitely not for an election because we're not doing anything about elections. And then from there, the next screen, we're going to set up our equation. We're going to say the age has to be greater than or equal to 16. Because if you're younger than 16, you can't get it. If you're exactly 16, you can. And if you're greater than 16, you can get one then too. Easy math. Anybody can do this stuff. Alright guys, now it's going to be your turn to solve this problem. A DVD costs more than $15, so you're going to figure out which one of these is going to be an appropriate answer for that. And hopefully you did it. Well, they have said that C is going to be the cost of the DVD in dollars right there. So we need to figure out, well, here C is smaller than 15, so that can't be it. Here, C is greater than 15, so it says more than 15, so yep, that one will work. Less than or equal to 15? Definitely not. And some of you may have tried to pick this one here that said C is greater than or equal to 15 because we used an or equal to last time, but this time it doesn't say at least or equal to. It says it's more than, which means $15 is not going to be enough to buy that DVD. Your correct answer is going to be answer B. Because an inequality like x is greater than 5 or y is less than 100 has infinitely many solutions, it is impossible to list them all. So inequalities can be graphed on a number line, And the number line helps you to visualize the values that make the inequality true. In other words, what numbers will work in that inequality that will make it a correct answer. When you graph an inequality on a number line, you're going to place a dot on the value shown in the inequality. An open dot means that the number is not included, in other words, less than or greater than. And a closed dot means that the number is included, less than or equal to, or greater than or equal to. If you go way back in your Wayback Machine to when you were a little kid and you were plotting numbers on a number line, you always plotted them with a closed dot because you were saying that that location equaled that amount. Same thing now. You're going to use a closed dot if it's an or equal to, and it's not an or equal to, then it's going to be an open dot. After that, you're going to draw an arrow in the direction to include all the solutions. We're going to take and watch this video to see exactly how it's going to be done.
Graph inequalities on number lines. Inequalities can be graphed on a number line. The graph helps you see the values that make the inequality true. Graph the inequality x is greater than 3. Because the inequality is greater than 3, draw an open dot at 3 on the number line. When graphing inequalities with a less than or greater than symbol, an open dot is used to show that the number is not a solution. Draw an arrow and shade to the right of the dot all numbers greater than 3. The values in the shaded region make the sentence true. Consider another example. Graph the inequality x is less than -1. Because the inequality is less than, draw an open dot at -1 on the number line to indicate that -1 is not included in the graph. Draw an arrow and shade to the left of the dot all numbers less than -1.
Now I should add, you don't have to shade your arrow that hard.
True. Let's try another example. Graph the inequality x is less than or equal to 2. Because the inequality is less than or equal to 2, draw a closed dot at 2 on the number line. When graphing inequalities with a less than or equal to or greater than or equal to symbol, a closed dot is used to show that the number is a solution. Draw an arrow and shade to the left of the dot all numbers less than or equal to 2. The values in the shaded region make the sentence true. Consider another example. Graph the inequality x is greater than or equal to -7. Because the inequality is greater than or equal to -7, draw a closed dot at -7 on the number line to indicate that -7 is included in the graph. Draw an arrow and shade to the right of the dot all numbers greater than or equal to -7. The values in the shaded region make the sentence true.
Well, that looks pretty simple, and we're going to dig more into that when we come back for part 2 of this video. So go ahead and stop this one and log in and watch part 2 as we continue in to our study of inequalities.